Everyone. Thank you so much for coming out and for your time. So I'm talking about probably my favorite topic in the world right now, which is biometrics in AR and VR, what we also call the infinite feedback loop, which is a fun way to think about it. I'm the CEO. My name is Josh. I'm the CEO of Cubicle Ninjas. We're a design and development agency. And so that's just a really fancy way of saying we make stuff. So we make all different sorts of creative things all across the spectrum. Quite a bit of what we've been doing lately is building VR and AR applications. And so we've built the first VR apps for companies like Microsoft or IBM, the US government, and in a few different cases. And we've built our 40th VR app. So what's been really fun to see how these sorts of ideas translate to that. On the side, we've been building our own apps, and the ones that we're really interested in are things around relaxation and wellness and health. And so to get into this topic, I wanted to start with a thought experiment by one of my favorite people, Richard Feynman, who's a physicist, also outside of Chicago. And so he had this thought experiment. Suppose a bug of sufficient cleverness could sit in the corner of a pool and just be disturbed by the waves. And the nature of those irregularities, the bug could then figure out who jumped in and where, and when, and all that sort of fun stuff. And if you really think about it, like, that's exactly what we're all doing all the time. Like, we're dealing with this exact issue. Like, we don't really have the main inputs themselves. We are getting waves. Everything's waves at all time, everything in this room. And we have some sort of built-in ways to get those. We have a tiny little hole in our eye and some other areas where we have specialized forms of those waves. The vast majority of waves are completely and utterly lost to us. And so this room is an ocean of information and data that we will never see. And what's really kind of crazy is, like, that's so much part of our lives that we've kind of accepted. We just sort of accept that the 85 to 100 billion neurons that are firing at every moment in our brain, or the 23,000 breaths each day, or the 100,000 heartbeats are never going to be part of that, and any more than simply a stat on paper, that we'll never see those or interact with those in an intimate way. And so you can start to see why people get a little bit frustrated, right? Like, we are like that bug. We're completely lost, and we're guessing at the actual reasons why we think and why we feel, and we're looking at these abstract outputs down the line. Wouldn't it be cool to see where those changes take place? So that's why we're ultimately frustrated, I think. To me, this is the topic this is the reason I'm interested in this topic. The closer we get to the root, the more we can understand who and what we are and why we make these decisions, and even if they're irrational. If we start to understand those things about ourselves and get more access to this wave data, can we become better people? Can we become better communicators? Can we share information more clearly and directly, and maybe instantly? And so, and can we do this socially as well? Can this information then roll up to everyone on a social basis? So this is the kind of question that we're sort of pondering on the high level. This is why I'm interested in biometrics, and specifically for AR and VR, why I think biometrics for AR and VR are going to be a massive game changer. And I think we're starting to see some of these things happen today. But what we'll do in this presentation is talk about why biometrics for AR and VR versus other computing platforms, what data we can expect to capture with current devices on both, what's on the horizon, just at the very, very near horizon, what's a real-world example of some of this in use, what feedback loops we're actually seeing are most effective, and then finally, what's the future? So one thing is that if we take a look at almost all the uses of biometrics across the forever of computing that we have, a lot of them are conscious. So we actually have to manually move our body to distort and to get interaction with them. They're happening when we make an input, so they're not continuous. And so those two things, and we tend to use them for very limited use cases. So maybe security or payments or health, but once we're done putting our finger on something, they go away. The other ones that are more specialized cost so much money that nobody gets access to them. And additionally, they're often based on a single sensor. So because of that, the data is not so great. Additionally, because they're just built on traditional ways, the ability to capture amounts of data is fairly limited. So the refresh rate is kind of tiny because it's a mobile phone. So basically, while we have biometrics as part of, and biofeedback as part of traditional computing today, we don't really use it, and when we do, we get these like limited 2D outputs that aren't very interesting. So why VR and AR? Why is biometrics unique for this platform? Well, the fun thing is, because we're covering all of our inputs, that's a perfect time for us to also capture data at those exact same inputs. Unlike mobile or desktop computing, this is a continuous thing, and it also happens without my input. So it can be happening at every single moment, and I'll never know. Additionally, the refresh rate in these devices are massive. So usually because they're run either by computers that are meant to have certain pipelines to have high refresh rates. But we can have up to 120 hertz a second on some of the higher end VR devices, which makes it amazing for us from a data perspective. And additionally, the other benefit is that we can have multiple sensors. And so earlier there was a talk kind of about from NeuroSky, and they were talking about how you can combine some things with other things and make some sort of super thing. But the reality is not many people are going to do that. And so what's cool is that by building multiple sensors into HMDs or AR devices, we don't have that as an option. Everything's built in, and we are able to cross-pollinate those data pieces to get a really powerful experience. And so kind of, just to roll up, like all of this magic happens unconsciously, and we're capturing it at 120 hertz without the user ever knowing, simultaneously broadcasting this potentially to other areas where we can learn more about that data. So when we look at like the current landscape of where all this stuff stands, if we take a look at the left, we'll see kind of like the low end where we almost have nothing. And on the right, we're starting to move towards things where we're starting to get more ability to capture other elements. So in black is when we are actually able to capture some of this data. And so all of this is also by default. This is with no add-ons or anything else along those lines. So cardboard, we don't really have anything. We have basic head movement on a rotation. But as we get over to things like the Rift, the Vive, and Daydream, we have the ability to capture breath through things like the microphone. We can capture hand movement in 6 degrees of freedom. And then even with the Gear VR, every Gear VR, the reason we do a lot of work with the Gear VR is because every Gear VR ships with a heart rate, oxygen level, and stress. We can use those pieces to get HRV, which is heart rate variability. So while we're still early days, we're still seeing more on that right-hand side. We see more of those that are on that are not than aren't, and that to us gets us really excited about the future and when we start bundling in more sensors. So one of the things that's really mind-blowing is that like all this probably sounds like science fiction and stuff that will never happen, and maybe like 20 years from now we might have it. But the crazy part is the stuff that's on the horizon is actually out on the show floor here. So some of the new technologies are really exciting. So one of those is EEG. By building EEG, and I think if you've been paying attention to VR and AR in the past few months, you'll notice like every 2 weeks you're hearing about a new EEG player. And so EEG being built into the masks of these devices or different areas, we're able to capture so many different things on an unconscious level. Those include the workload, how hard is a task, the ability, the perceived intelligence of the person, the creativity, their stress level, their ability, their emotion, is it positive or negative emotion? All these sorts of things are captured by EEG, and they're done unconsciously. And so this is where it starts to get really fun and super like cool about where we're just about to be 6 months to 12 months down the line. And so as an example of this in context, how we're actually using this tech today to do different sort of things. About mid last year, we launched an app called Guided Meditation VR, which is a virtual reality relaxation app. So you can put it on and go to a beach or go to space and just take a breather. And we really started with this question of how do we verify that this is actually helping people? We didn't have to, we could just made an app, but we wanted to know like that this was working and understand what was most effective and why. And we did two things. One, we created a modified pain scale that the user takes before and after. They can then get randomized results and choose where they're feeling in that spectrum to see if there was a difference. But we also set it up so that they can capture their heart rate. So they capture the heart rate both before and after, and we're able to take that delta change and make and understand a little bit more about which virtual worlds are most effective. In the past 10 months, we've captured 2.5 million heartbeats across hundreds of thousands of users, and we've learned an absolutely massive amount. It's the world's, as far as I know, the world's largest biometric trial that ever happened, and it kind of took place by accident. And so what's fun is we've learned all this crazy, interesting data. For example, we've learned which spaces are most effective, and a lot of the stuff that we originally looked into around environmental psychology, for example, light, lush green foliage, water, those things actually trigger these sorts of benefits in us naturally. So we learned that. We also learned that, that the exotic other is really the most effective. So we can, by determining where your local area is, either your city or your country, we can then serve you content that is more effective. Because this is beautiful California, no one will want to go to a beach. No one will want to hear an American accent. But we can dynamically change it so that you get a lush, beautiful forest and a British accent, and that will actually increase your effectiveness. And finally, the thing that blew us away too was that changes dynamically based on weather. So if it's raining outside, people are gonna wanna go to a beach again. It's very interesting. And so we can use all these little pieces of information to drive it. And again, this is from one biometric data point. Imagine when we have multiple, and in this case there is a conscious input, so multiple unconscious. And you know, the other thing that we found was that time on device and repeat visitors increased when they used biometrics. So even from just that basic level, ignoring efficacy, like that basic level, we're able to learn that biometrics actually were adding some value. One other area that we're starting to explore is that kind of change between these old model of having things that you have to interact with and now setting it up so everything's interactive by default. And so we're actually showing some stuff here in the kind of the playground area with the ability to have a sensor on that you don't even know is there, and it's doing some really fun things. We call this like, phase 2, this is our second gen, and these are what we would call responsive realities. This is Japan, and Japan before is a very beautiful sunny day, but if you have a bad day and you're not feeling so hot, when you put it on, Japan will start to thunderstorm, it will get very aggressive, wind will blow, and the world will flood around you. It's a really clear, easy way to understand what you're doing and how your body is feeling. Across the bottom we have EEG sensors, so we're able to, we actually don't show those in VR, but outside of VR we show them so that people can see what more about. We also have another demo that is very wintry, and as you begin to relax, the world around you melts and the world changes. It's a lot of fun, and it's an interesting way to present that content to a user. Today's demo, the one that we'll be showing actually tomorrow and the next day, is using some fun new EEG stuff that we've been playing with. And this one actually changes the world. So you are by default in grayscale, but as you relax more, you go to Technicolor. So it's a really nice, simple way just to understand how the world works for you. The one thing that we found in terms of user interface is you'll notice all these are subtle, right? We don't have a big gauge that says, you are now relaxed, congratulations. And the reason is what we've learned is that like when we did that originally, we put a giant EEG or EKG sort of situation. So, and what ended up happening is people freaked out. Their responses and their data went through the roof. And so especially for real time, we want to kind of represent that in a different way. So the things that we're trying to do is take senses and re-represent them through other channels. So light, color, sound, shape, size, movement. Those are really important versus traditional 2D GUIs. And this is just an example of a breath creation we have. So as you breathe, we use all these different factors to communicate that to you. There's no 2D gauge bar, but it's something, just another way to translate it to understand intuitively that that's your breath. One final note is that like all of this stuff, it doesn't matter if you don't actually have access to the data and you're unable and you're able to play with it. If you know, the cool part about this right now, and the part that really has frightened us, is that most of the research trials that we've looked into around biometrics are massively tiny. They're like 50, maybe 100 users. So with VR or AR, you get to have data sets that are just 100x in one day what you would see across a decade of clinical research. And so having access to that data is really important. So what we've started to do is build dashboards. And these are highly secure dashboards that allow you to access the data. You don't have to be technical, but then you can go in and play and understand and manipulate and try to understand what's going on in our heads. So the final note is really just everybody. You know, we're all looking inside to try to find that next frontier. The world is largely a discovered place, but the inside of us is the one that really remains completely unknown. So our hope is that AR and VR is that next frontier. We're starting to see the initial pioneers, but we need more people on board. So you know, if this is something that's interesting to you, come on board and let's go figure that thing out together. So cool. Thank you.